Okay, then now we talk about some other type of op-amp circuit. Okay. So with this property, okay, when we have negative feedback to the op-amp, okay, we will get V negative and V positive. In the same will be the same voltage, okay. The voltage in between these two pins is zero. And the property of op-amp is also In is zero. No current flow into the op-amp. Okay. So this is the inverting amplifier, and this is the gain of inverting amplifier. Okay. Then if we connect with many sources to the negative pin, okay, again we will have I in is zero, right? It's zero. Therefore, I1 plus I2 until In plus IF will be zero, right? We take KCL here. We get this equation, right? I1 plus I2 plus until In, we get negative IF, right? So I1, what is I1? I1 is Vs1. So with this connection, V positive is zero. Therefore, V negative also zero, right? Because if V positive, we take it to the friend. If V positive is zero, V negative also zero, right? Yeah, with this property. So I1 will be Vs minus zero, right? Minus zero by Rs. Minus zero by Rs1. Similarly, I2 will be Vs2 divided by Rs2. And for any branch in the left hand side, In is Vsn divided by Rsn. So if I substitute I1, so I get Vs1 divided by Rs1 plus Vs2 divided by Rs2 plus until Vsn divided by Rsn equal to what is If? If will be Vout divided Vout minus zero, right? Vout minus zero divided by Rf. So it's Vout minus zero divided by Rf here. So Vout is the relation of some value that's calculated from the summation of the voltage divided by the resistance. Okay, so we call this is summing amp. Okay, summing amplifier. So if I take this circuit, for example, if I take this circuit. Here. And if I use the same value of R input, if we use the same value of R input, if R input is the same value, we can rearrange, right, into the summation of the voltage. Okay, the summation of the voltage. So So if I select RF as 10, and maybe this is 1 and 1, and if this is 10 volt and this is 5 volt, what is V out? So the relation is 10 by 1, right? Plus 5 by 1, right? Here, and what are equal to negative V out by 10, right? By 10. So we, in this case, V out is minus 10 divided by 1 into 10 plus 5, right? This is, so this is the gain, negative gain also, but is into the summation of input voltage, right? Into the summation, so we call summing amplifier. Okay, summing amplifier. So summation of input voltage with the proper selection of the resistance value, we can get the summation output with some increase, right? With some increase of its magnitude. This is summing amp. Okay. So with this equation, we can write down in the short equation term, right? This equation we can write in this equation, right? And RF is constant with between RF to this side, so V out is RF into this term, right? RF multiply with this term, so V out equal to minus RF into this summation term, right? This summation term is Vs n by Rs n equal what? N start from 1 to n, right? Yeah. Or we can put RF behind the summation also, right? But RF will be constant, right? This value will change. These two Vs and Rsn will change together like this. So if we select the same input resistance, so we get the summing amp, right? Or we can also, if we use different resistance, also we weight to different weight to our input voltage, right? Sum with different weight as well. So it's sum with different weight, right? Okay. So we can design the circuit to get the proper V out in corresponding to many input signal as well. No question? Okay. Then another type of connection, so we call non-inverting. So the output is not inverted, right? So again, we take negative feedback with negative feedback here. So I in is 0. And V negative approximately V positive, right? Here. And V positive here. Then in this case, we take KCL at this point. We get IF equal to these two current, IS and IN, and IN approximately 0, right? So IF equal to IS in this case. And what is IF? IF will be V out minus V negative, V out minus V negative, divided by RF here. And what is IS? IS is V negative minus 0 divided by RS. Right? IF is V out minus V negative, right? Divided by RF. And IS V negative minus 0 divided by RS. So this is, and V positive is approximately Vs because no current flow, right? Without current, V positive will be Vs, right? V positive is Vs because I in is 0. So I in is 0. This is because I in is 0. So V positive and V negative are equal. So therefore V negative is Vs. So in this case, this pin will be Vs and this pin also Vs. And no current flow into the op amp. And I in is 0. Okay, ES. And IF and IS is equal. So these two terms is equal. We take these two terms equal. We get V out minus V negative by RF equal to V negative by RS, right? We substitute V negative by Vs. We get this relation, right? This relation, and rearrange this relation. What we get? To rearrange this, so V out by RF minus Vs by RF equal to Vs by RS. Then take Vs, take Vs to the same side. So V out by RF equal to these two terms plus together. Vs by RF plus Vs by RS. Then V out by RF equal to 1 by RF plus 1 by RS into Vs. This plus together we get continue here. V out by RF equal to plus these two together. So RS plus RF by RS. RF, right? And then into Vs, right? We cross these two terms together. 1 by RF, 1 by RS, right? We need to get some common, right? Common of RF. Then RF. Then the relation between V out and Vs. V out is, I move RF here, we cancel RF, right? We cancel RF, we get RS plus RF by RS into Vs. Finally, we get V out equal to, here is 1 plus this term and this term, right? RF by RS into Vs, right? V out will equal to 1 plus RF by RS right? 1 plus RF by RS into Vs. This is the relation, right? V out by Vs is this value. Okay. So whatever Vs, we can get V out with this relation, right? With the proper selection of RF and RS. And the signal is not invert. The gain is positive value. Okay, what different to the inverting amp? The gain is negative value, right? Inverting amp, the gain is negative value. But in this case, the gain is positive value. So for non-inverting amp, the gain is 1 plus RF by RS. Okay, but the connection is different, right? We need to connect the reference to inverting pin. So, with the proper selection of RF and RS, we can increase Vs into Vout, right? For example, if I select RF at if RS 10 ohm and RS maybe 2 ohm, and if we have Vs 10 volt, what happened to Vout? Vout will be 1 plus RF by RS, right, into Vs, right, and it's equal to how much? 6, right? 6 into Vs, and in this case it's 60 volt, right? So with this connection, with the selection of 10 ohm and 2 ohm for RF and RS respectively, we increase the input by 6 times, right? Okay, by 6 times. So the gain is 6, right? 10 by 2 plus 1. 10 by 2 plus 1 is 6. And if the input is 6 ohm, we get 60 volt out, right? 60 volt out without inverse the signal. So without inverse the signal, so we call non-inverting amp. Okay. Non-inverting amp, the relation is this. Then also we can have the circuit called voltage follower. So whatever Vs, we will get Vout in the same value with this value. Okay, this is a voltage follower without any resistance. Okay, we call voltage follower. Okay, just follow the voltage here. And we have inverting and summing amp, right? We have so far we have inverting amp. We have summer amp, right? Summer amp. We have non-inverting amp, right? Non-inverting amp so far. And we also have the differential amplifier. With this connection, we can get differential amplifier. Okay. So with this connection, we take V1 here and V2 here, right? And we take the non-inverting pin as reference. So with this connection, V positive is here. So this is V positive, and this is V negative. V positive is we can use KVL into this loop, or we can use voltage divider. With voltage divider, we supply V2 here. With voltage divider, V positive is R2 into V2 divided by R1 plus R2, right? With voltage divider from this, right? V positive, right, is R2 divided by R1 plus R2 into V2. Okay. And here, I1 and I2 and I2 is 0. I1 plus I2 will be 0 because I in is 0, right? With op-amp, I in is 0, so these two plus together. And I1 is V1 minus V negative. And V negative and V positive are same, right? Because V negative equal to V positive, right? I1 is V1 minus the voltage, and these two pins we get the same voltage, right? And then divided by R1. And V out also same. V out minus V positive divided by R2 here. Okay. And then these two together plus is 0. So I2 equal to I1. I2 equal to I1 is this property here. So we take these two value equal. These two value equal. Therefore, V1 minus V positive divided by R1 equal to V out minus V positive divided by R2. And then we substitute V positive here, V positive here, and V positive here, and we can rearrange into this form. Okay, substitute V positive, finally we rearrange into this form, and then it become this form later. Okay, so utilize this. So I won't do this here. Okay, you can, if you believe it's true, it's okay. If you don't believe, you try. Okay, you try it later, right? How come to this final formula? Okay, so I will do it here, right? Because it takes some time, right? So with this value V positive disappear and we get V2 here, right? So in the formula it will be V1 and V2, right? If we arrange this side, we get V out equal to R2 divided by R1. R2 divided by R1 into the difference between V2 and V1. So we call differential amplifier. Okay, the difference between V2 and V1 is output. So this type of circuit, we can get the difference between two voltage, right? Two input voltage is different. Right? So with the proper selection of R2 and R1, we can get the proper V out. For example, if I take R2 and R1 the same value, so in this case maybe 10 ohm, R1, R2. So if I take here 10 ohm and 10 ohm and V2 10 volt, V1 is maybe 2 volt What is V out? So V out is V out is R1 by R2. So 10 by 10. V2 minus V1, V2 minus V1, right? Is therefore 10 minus 2 we get 8 volt, right? So V out is the difference between two input source, right? If we have two input source, we would like to get the output as the difference between two sources, right? Or we can put some gain as well. If we take R1 and R2 with some value, right, we can increase the output, right, of the difference between two sources also. So this is a differential amplifier. So far we have many types of op-amp application. Okay. Inverting amp. This is inverting amp. The output is negative feedback by with source resistance with negative. Summing amp is the summation, right, with negative value. Non-inverting amp is 1 plus RF by RS. This is the different gain, but it's not invert, right? Yeah, voltage follower we just follow. And differential amp is the difference between two sources, okay, with some gain. Okay. So you don't need to remember, but you can take a note. You need to remember the formula, okay? But you need some understanding. So when you face the circuit, you need to know what is this circuit. It's non-inverting, it's inverting amp or summer amp, right? You need to know that, right? It's not just substitute the value to the formula when you face the circuit, right? For example, what is this circuit? Inverting amp, right? Just inverting amp. This circuit is the inverting amp. So what is the gain of inverting amp? RF by RS, right? Minus RF by RS here. The gain of this circuit is minus 5 by 1, right? So the relation between V out, so V out is equal to minus 5 by 1 into V in is 1 volt, is minus 5 volts, just like this, okay? And this is the gain of inverting op amp, right? Next. So what is this circuit? This is also inverting amp, right? This is also inverting amp. And the gain is 10 by 2, right? 10 by 2 with inverse, right? Just single. 10 by 2 is 5. 5 into 5 is the invert value. Like this, right? Yeah. Or we can take the property of the op amp. Right? I in is 0. V positive is 0. And we can solve for V out as well. Yeah, we can just keep I in, this is 0. And this is also V here is 0 and 0. And we can take 5 minus 0 by 2 equal to this current and this current, right? Minus VO minus 0 by 10. We can take this. We can take KCL at this node as well, right? This is IS and IF, for example. IS equal to minus IF, right? Plus together. We can solve from the equation as well. We get the same thing, right? resolve from that equation, right? In KCL, with op-amp property, right? Or we can just take the formula inverting M, right? Inverting M is V out is minus 10 by 2 into Vs, right? It's minus 10 by 2 into 5. This is solution. Okay. Then, what is this? We have VA and we have VB. Summary or differential M. Let's see. Summary M or differential M. So you can back to this. This is 2 volt, this is 5 volt, and this is 14 ohm and 11 ohm. Summary amp or differential amp? Differential amp, right? This is differential amp. You can take the formula of differential amp. 14, right? 11 and 14, right? 11 and 4. R1 is 14, right? R2 is 11. For 14 and 11, like this, right? This is differential amp, right? Here. Or you can take the KCL at this node. At this node. So if this is 5 volt, what happened to this pin also 5 volt, right? This is the op-amp property, right? This 5 volt and this 5 volt also. And the current flow here, no current flow here. So without the current flow here, IS and IF plus together is 0, right? IS plus IF is 0. Therefore, VA minus VB, right? Here. So this is V. Here is VB. So the other pin is also VB, right? With op-amp property, right? With the op-amp property, if we connect 5 volt here, the other pin also 5 volt, right? So VB. VA minus VB. VA minus VB. Vout minus VB also. VA minus VB by R1. Vout minus VB by R1, right? IS and IF. So IS VA minus VB by R1. Vout minus VB by RF is IF, right? We substitute the value. VA 2, right? VB 5. Vout, we leave it, and VB is 5 divided by R1 14 11. So we solve for Vout, we get this value, right? On the other hand, if we use the formula of differential amp, what is the relation of differential amp? Differential amp R1 and R2 is here. The gain here, and this is the difference, right? V2 minus V1. So differential amp Vout equal to R2 by R1 into V2 minus V1. So it's V2 minus V1. In this case, VB minus VA. R2 by R1. VB minus VA, right? By using the formula, right? So equal to how much? 11 by 14 into 5 minus 2, right? So we should get the same answer. No? 14. Oh no, this is 14, right? 14. Not same. 5. Check it again. Eleven by 14. That's it. How much we get? 2.36. 2.36. This is mistake, right? We check this. Maybe mistyping. 2.36, right? So we check with this. You can recheck this. Okay. I think 2.36 should be correct, right? That's simple. Okay, possible. Please write. Next. So now, go. Okay. About right. What is this circuit? Differential, right? Differential amp. This is differential amp. This is different. This is differential amp. And why Vout is 0, I don't know. This is 4 volt, this is 5 volt. Why? 0 amp. Yeah, maybe because of the gain. Should not be 0. Five minus this is 4 volt, so this is 4 volt also, right? So this is the current flow here. 5 minus 4 divided by R1. So 5 minus 4 divided by 1 equal to 4 minus V out, right? Equal to 4 minus V out divided by 4, right? Divided by 4. So in this case, what is V out? This is 1 equal to 1 minus V out. So in this case, V out is 0, right? From this. Okay. So square string circuit, right? 4 is 4. Okay. Okay, because there is no resistance here, right? So this circuit is some special, not exactly differential. Okay. What about this? Determine R1 to obtain the gain of 10. So we would like to get V out is 10 V1. We would like this, right? How much for R1? How much for R1 to get the gain of 10? Right? So this is non-inverting amp. With this non-inverting amp, we get V out by V1. V out by V1 is the gain of non-inverting amp. Okay. So non-inverting amp is this circuit, right? Here, right? This is non-inverting amp. The input, the voltage input into positive side here. The voltage input to positive side. So negative, positive, and this is plus minus. This is V1. And this is like this, right? This is non-inverting amp. Now, this is 14 k ohm. This is R1. And we try to solve for R1 to get the gain of 10, right? So R2 is 18k. How much R1 to get the gain of 10? And with this equation, we get R1 as 2k. 2k ohm. If we use R1 at 2 kilo ohm, with 2k ohm, we will get the gain of 10. Okay? This is okay. What is this? Any people waiting? No? Okay, determine V out with this circuit. So with this circuit, we can use the property of op-amp. If this is, we don't know the voltage here. This is V1. V1 is 4 volt, and V2 is 6 volt. R1 11 ohm, R2 18 ohm, RF 15 ohm, R1, oh sorry, R1 11 ohm here, right? This is R1. I don't know what is okay, maybe this value 6 ohm. 6 ohm here. And no current flow here, right? Zero. And the voltage are same, but we don't know what is the voltage here. So we call this voltage Vx, and here Vx. So V1 minus Vx is the current flow here. V2 minus Vx current flow here, right? So take KCL at this node as a positive node. KCL as positive node is V2 minus Vx divided by R2 equal to Vx divided by Ri. Okay, here this is Ri. So this current and this current, right? This is I1 and this is I2. I1, I2 equal, right? I1 and I2 equal. So we arrange, we get Vx to this value. Or we can calculate Vx first from this relation. If we substitute Ri is 6 divided by 6 plus 18, right? Into 6. We can get the Vx value first, and this is will be the same value with Vx. Okay, but in this example, we leave it Vx. Okay, you can do this method. You can solve for Vx first, and then you can go ahead, right? And here, V1 minus Vx is this current will be equal to Vx minus Vout, right? With this current. V1 minus Vx by R1, Vx minus Vout by Rf here. With this relation, Vout would be Vx, Vout would be Vx into 1 plus Rf by R1. Right? With this arrange, we rearrange this, we get minus Rf by R1 V1 as well. So we can substitute Vx here. Then we get this value. Vx is this term, right? This is the term of Vx. This is Vx term. So this is, we can solve for Vout. Or we can solve Vx into the value, into some value. Substitute here. Substitute the value here. We get Vout of this circuit. Okay. This is the op-amp circuit of this connection. In fact, this is a kind of differential amplifier here. Okay. Yeah, what is this? This should be the summer amp, right? Summer amp. The summer amp. Here is the summer amp. V1 by R1 plus V2 by R2 plus VT by R3, right? Equal to Vout by Rf with the negative value, right? Equal this, and this, right? Vout by Rf. This is 0 volt. So this summer amp, we can get the summer amp. We can use the summer amp formula, right? We can just use the summer amp formula. We get the output of minus 16 ohm. Okay. So, which type of amplifier circuit should be in the final exam? No? Summing. Maybe many type. You have equation of 5.1, 5.2, 5.3, for example. Okay. Okay. And this is your homework, right? With final answer. Okay. And equation. This is summer amp, right? This is non-invert. This is non-invert, right? Not sure. This is what is it? This is inverting amp, right? It's a simple one. Okay. Inverting amp. Okay. And equation. So if no question, next time we talk about digital logic circuit, and this is not difficult, but there is some knowledge that you try to learn just like this. Okay. The difficulty may be equal, but it's different topic. Different topic, that's all. Okay. And it's really good to final exam also for digital logic. Okay. Okay. So question, see you next week, the last week. Okay. Right. So tomorrow you do op-amp back, right? I think. Try to make more understanding in the laboratory. Okay, see you.